Okay, let's do some correlation and regression classwork. So you can see we're going to have a problem here on income and occupied, cost and age, household amount and income, and then origin, destination, distance, and we have all of those variables here in our data file. All right, so let's start with the first question. All right, so a suburban hotel derives its revenue from its hotel and restaurant operations. The owners are interested in the relationship between the number of rooms occupied on a nightly basis and the revenue per day in the restaurant. All right, so does any kind of relationship exist between income number and number of rooms occupied? Okay, so we want to start with a scatter plot. So what we actually need to do, because we unfortunately cannot do it here in JASP, is we will go over to our regression classwork data, regression. All right, regression, here we go. So I'm going to open the CSV in Excel. All right, and if we want to do a scatter plot, we'll just highlight our column A and B, go into Insert, and here is our little scatter plot little icon, so we'll click on that. All right, and so here, this is going to be income is on the x-axis and occupied is on the y-axis. Now, ideally, we actually are going to use occupied to predict income. And so if we right-click on this and go into Select Data, we can switch, let's see, how do we... Well, we may just have to do it this way. So for our X data, there's our X data. And for our Y data, there's our Y data. All right, and we can say OK. All right, and so here, now we are looking at number of rooms occupied and restaurant income. All right, so what kind of relationship do we see there? And so it appears as though there's somewhat of a positive linear trend. Not sure how linear it is, not sure how positive it is because of these over here. If we didn't have those four, we would clearly see a positive linear trend. So I think that with the scatter plot, we can probably say positive. Let's see here, we can probably say positive linear trend. All right, determine the correlation coefficient between the two variables. All right, so we want to go into correlation, and we're going to put in why do I not see, let's oh, there we go, sorry. Income occupied. All right. And we just want to leave it checked on Pearson. All right. And then with the hypothesis here, is it a one-tailed or two-tailed test? Are you like wanting to know if it's correlated positively, or are you wanting to know if it's correlated negatively, or correlated would be either positive or negative? All right, so we actually said we think it's positively correlated, so we check on correlated positively, and we get a Pearson's R, so the correlation coefficient is 0.423. So 0.423, so we would refer to this as a, anything above 0.4 to 0.7 would be a moderate positive linear correlation. All right, what percent of the variation in revenue in the restaurant is accounted for by the number of rooms occupied? All right, so here, all right, starting with C, we're going to need our regression equation. So we're going to go into linear regression, and we are predicting income by rooms occupied. All right, and so we see here that we've got our coefficients and our ANOVA table and then our model summary. And we are looking at R squared, which is the coefficient of determination. So we have 17.9% of the total variation in restaurant income is explained by rooms occupied. All right, calculate and report the regression equation. All right, so now we need our coefficients table. We look at the intercept and occupied. They are both significant. All right, so we will say y equals 1381.988 plus 1.478 occupied. All right, test the significance of the slope. All right, so here we're going to have a null that says slope equals 0 versus an alternative slope, and we need our not equal to. All right, insert. So slope not equal to 0. All right, the p-value on the slope is 0.035. And so we conclude the slope is significantly different from 0. All right, interpret the slope. All right, so here, for each change in x, y changes by the slope. So for each additional room occupied, the restaurant income increases by a whopping $1.48. All right, interpret the slope. When there are 0 rooms occupied, all right, the value of the income is the intercept. All right, so when there are 0 rooms occupied, the restaurant income is $13.81.99. All right, use the regression equation to predict the income for 50 rooms occupied. So we want to plug 50 into our equation. So we got our intercept plus 1.478 times 50. All right, and I'm pulling out my handy dandy iPhone. All right, so 1.478 times 50 plus 1381.988 gives me 1455.888. All right, so that would be the predicted amount in restaurant income for 50 rooms occupied. All right, moving on. All right, so now I'm considering buying a fuel-efficient used car. The data represents several options with the estimated cost to purchase and the age of the vehicle. All right, does any kind of relationship exist between cost to purchase and age of the vehicle? All right, so we can get rid of this one. And here's cost and age. And we want to insert a scatter plot. So what do we see here? Clearly, as age increases, value, all right, so as age increases, all right, the value goes down, all right. In other words, well, again, it'd be nice if these were flipped, which we can do. Let's see, we can go ahead and do that. No, this is not, let's cancel out of here. I can't see there we go. All right, so select data. All right, so for our X's, we actually want age. And for our y's, we want value. Okay, so here, now we can see, all right? So as the car gets older, the value clearly decreases, so we see a negative linear trend. All right, and we want to compute the correlation coefficient. All right, so we go into correlation, and we put in cost and age. All right, and we're interested in, are they correlated negatively? All right, and so we see this negative 0.822, which says there is a strong negative linear relationship. All right, for the remaining questions, we're going to need our regression. Oops, and that should say strong, not string. All right, so let's go into regression, and we want to predict cost from the age. All right, so we see that intercept and age are both significant. All right, and we can look at our R squared here for the coefficient of determination. So 67.6% of the total variation in cost to purchase is explained by age of the vehicle. All right, calculate and report the regression equation. Well, we just said that both the intercept and age were significant, so here are our unstandardized coefficients. So we've got y equals 18,357.737 minus 1533.634, age of the vehicle. All right, test the significance of the slope. Our null is slope equals 0. Our alternative is slope. And let's go up here and copy our not equal to. All right, and our p-value, let's see if we go over here to age, is less than 0.001. So we reject the null. Conclude the slope is significantly different from 0. All right, let's interpret the slope. For each additional x, y changes by the slope. So for each additional year of age, the cost to purchase decreases by $1,533.63. All right, interpret the constant. All right, so we have this 18,000 number. What does that represent? Well, that's the price of a car that is 0 years old. So the cost of a brand new car is $18,357.73. And just so you know, this what we're seeing here is on average. All right, use the regression equation to predict the estimated cost for a vehicle 4 years old. All right, so we have our slope, y equals 18,357.737 minus 1533.634 times 4 years old. All right, and again, plugging this into my iPhone, 634 times 4. All right, and add that to 18,357.737. I am getting a value of $12,223.20. All right, moving on. Harris Teeter is considering expanding into upstate South Carolina. As Director of Planning, you must present an analysis of the proposed expansion to the Operating Committee Board of Directors. As part of your proposal, you need to include information on the amount people in the region spend per month for grocery items. You would also like to include information on the relationship between the amount spent for grocery items and income. All right, so we're interested here in grocery items and monthly income. So let's go over to Excel. We'll get rid of our car scatter plot. All right, here is groceries and income. Scatter plot, and we clearly see a positive linear trend. So as income goes up, you spend more on groceries, right? That makes sense. All right, so we see a positive linear trend. All right, we want the correlation coefficient. All right, so we go into correlation, and we've got, I should probably look at what do I want here. We want amount and income. All right, and we are testing a positive correlation. And what we see here is a correlation coefficient of 0.945, which is a strong positive linear relationship. All right, what percent of the variation in the amount spent for grocery items is accounted for by monthly income? All right, so now we need our regression. So we go into regression, linear regression, and we put in amount spent on groceries explained by the income. All right, check to make sure everything, so we see our constant is not significant and our income is significant. All right, so again, that just means when we go to interpret this negative 74, that we can interpret it as 0. All right, so, all right, our R squared for this model is 0.893, so 89.3% of the total variation in amount spent on groceries is explained by income. Makes sense. All right, what about our regression equation? All right, so we've got, look down here at our unstandardized coefficients, and we have y equals negative 74.367 plus 0.134 income. All right, test the significance of the slope. Slope equals 0 versus an alternative slope not equal to 0. We get a p-value equal to, on income, of less than 0.001. So we reject the null. And conclude the slope is significantly different from 0. All right, let's interpret the slope. All right, so again, for each change in x, y increases by this, right? So for each additional dollar in income, amount spent on groceries increases by 13 cents. So basically you're spending 13 cents of every dollar you earn on groceries. All right, now for interpret the constant, we go down here and we see that the constant is not significant. And so here we say cannot interpret because not significant, meaning it will not make sense. All right, we can try. Let's see here. If the income is 0, the amount spent on groceries is negative $74. And you see that just doesn't really make sense. All right, use the regression equation to predict the amount spent for grocery items for a household monthly income of $5,000. All right, so now we need our equation. We've got y equals negative 74.367 plus 0.134 times 5,000. All right, so again, going to my iPhone. I get $595.63. Can you think of any other independent or explanatory variables that should also be considered in this model? So this is just a thinking question. What else might explain how much you spend on groceries? How about number of people in the family? Obviously, if you got a bunch of teenagers, you're probably going to have to feed them a whole lot. What else is going to affect how much you spend on groceries? So maybe qualitatively, we could think, is there a holiday that month, right? So open-ended, there's lots of things we can think of. All right, final question here. You are interested in whether or not distance traveled affects fare price for flights. All right, so let's go over to Excel and take a look at the scatter plot between distance and fare. All right, so here's distance and fare, and we are going to do a scatter plot. All right, what do you guys see? It appears as though there is somewhat of a positive linear trend, right? So as distance traveled increases, the fare seems to go up a little bit. All right, so we can say here positive linear trend. All right, we want the correlation coefficient. All right, so let me double check our variables here. So we've got distance and fare. Distance and fare. And we think they are positively correlated. All right, so we see a Pearson's R of 0.656. So this would be a moderate positive linear correlation. All right, and now we need our regression to talk about the coefficient of determination. So we go into linear regression, and we want to know if the fare is explained by the distance traveled. All right, and let's just check our coefficients. We see the coefficients in the intercept are significant, so we have something to interpret. And we go to R squared, and we see 0.430. So 43% of the total variation in fare is explained by distance. All right, we want our regression equation. All right, so we're going to look here in our coefficients table at the unstandardized coefficients. So y equals 147.081 plus 0.053 times distance. All right, we want to test that slope of 0.053. So a null of slope equals 0 versus an alternative of slope not equal to 0. We get a p-value of less than 0.001. So we reject the null. Conclude the slope is significantly different from 0. All right, interpret the slope. All right, so as distance goes up, this is what the fare increases by. So for each additional mile traveled, the fare increases by basically a nickel. All right, you pay a nickel per mile. What about the constant? When the distance traveled is 0. The fare is $147.08. And so what would this be? All right, and if you ever took any kind of economics course, this would be what's called the fixed cost of the flight. All right, use the regression equation to predict the fare for a 1,500-mile flight. All right, so we've got y equals our intercept, 147.081, plus 0.053 times 1,500 miles. All right, and plugging this in, I get times 0.053 plus 147.081. I am getting $192.08. All right, so hopefully this answers any questions you had on correlation and regression. One quick thing I want to go over, again, just to explicitly state with correlation as to what is weak, moderate, or positive. So weak would be either between 0 to 0.4 or negative 0.4. So really, I should say here, negative 0.4 to 0.4. So somewhere within 0.4 of 0. Moderate would be between negative 0.7 and negative 0.4, or between 0.4 and 0.7. And then strong would be between negative 1 and negative 0.7, or 0.7 and 1. All right, so hopefully that helps clear up with correlation what's weak, moderate, and strong.